I clean up a little bit and now I would be able to make the video. And the device is ready. And board of synchronization is ready. And it's working properly with the output coil. And the frequency of resonance is adjusted on that board. It would be very much interested for Arkasha if I make some of the explanation. Why do we use catcher and why do we use impulse system of Tesla? And then why we use resonance transformer? When we're dealing with resonance system or circuit, we're creating a potential of the top of the coil with respect to the ground. When we create resonance of the secondary, we have a high voltage. So we increasing the voltage. Why are we dealing with resonance circuit of Tesla, and why Tesla was using or utilizing capacitive components, capacitive reactance of the coil? What is resonance in resonance? We can drive primary coil using very simple transistor. So the current would be induced in secondary. So voltage will be high, but the current will be the same. So whatever we gave it, we've got back. But when we're creating a resonance of the primary circuit, then of course we need to use our block of driver circuitry, and let's say we give from the driving frequency driving circuitry 400 watts. We gotta understand that he uses word watts, but he writes on the paper volts. So in resonance we're getting about 10 kilowatts in primary, and now that is only in impulse, and we inducing the very high current of that impulse in secondary.
Тогда мы получим добавку по вольтажу и по амперам.
And now we have not only high voltage but high current in that impulse.
Сюда. То есть мы 10 киловатт импульс с добавкой вольта. Здесь получим килоамперы.
So there was 10 kilowatts in impulse. On a secondary we have with a high voltage, and we're getting impulse that is able to carry on kiloamperes in that impulse.
Для чего нужны килоамперы?
And why do we need kiloamperes?
Амперы на время разряда, то есть промежуток времени их воздействия.
We need kiloamperes in time of discharge. So when we're dealing with simple impulse, this impulse is going up, going all the way to the certain point, is going down. Now from that time of being at the highest amplitude, going down to zero, we're talking about the discharge of an impulse. And that's why we need a very strong impulse there.
Каждому проводнику и полупроводнику имеют, конечно, разные. Но вот эти килоамперы и вызывают ядерные процессы в проводниках.
We take semiconductors or conductors, then we could say that such impulse could impact nuclear structure of the conductor.
То есть в первичке приемной катушки.
So we have another coil here. We have that impulse in that coil.
Который и позволяет нам заряжать именно емкость нашей выходной катушки.
And now we are able to induce the impulse in the secondary that will have a very high capacitive component of that coil.
Ну и мегаамперами. Но мы работаем с килоамперами. Для мегаампер эта система очень маленькая.
This system allows us only to work with the kiloamperes, not megaamperes.
На самом деле вот этот аппарат получился очень опасным.
And this device is pretty dangerous. We have a 40 kiloamperes in impulse. The man could be killed in a matter of seconds.
Не то шоу, которое все дома собирают у себя и пытаются с нее что-то вытащить. То есть стандартную транзисторную систему или какие-либо разрядные. Разрядники ничего не дают. Только мощный ток первички за счет резонанса дает мощный ток в разряде выводства.
Further, he says that using the spark gap, we're not going to achieve anything because we need a strong impulse that I assume is the square wave in shape. I would have a problem with that statement as a spark gap was utilized by Torrio Capenazze as well, and spark gap is capable of creating a square wave impulse, and based on the speed of those impulses and the length of those impulses, which will then be controlled by the distance between the electrodes, we are able to get very similar effects. But the spark gap creates an impulse of very strong impurities. It is going from very low frequencies to very high frequency, up to 1 megahertz and further than this. But of course that impulse will have a peak as well. So if you are able to tune that peak to the desired frequency, which the system I assume is not working in frequency bigger than 200 kilohertz, then we can have a use for it, which is okay because spark gap cannot work really very high.
Так вот, когда мы запускаем все ядерные процессы здесь, мы можем заряжать нашу вторичку на выходную.
So when we use that very strong impulse, kiloamperes, with a high voltage on it to create the nuclear interaction in the conductor. Now in the secondary we are able to charge the capacitive component of the coil.
Он будет постоянно заряжаться. Согласно
And-
частоте работы всего вот этого контроля.
And that would be
Мощности выходного.
according to the self-resonance frequency of that circuit that I'm showing right now.
Мы же его будем заряжать, под него будем подстраиваться.
So one we're gonna be using to charge, and the other one we're gonna be using to tune.
Все. Дальше задача наша. За счет ключа просто эти электроны, которые мы имеем, уже толкать. То есть первичка.
Okay, and then we implement another circuitry that would be sort of keying circuitry, which will allow us to control the electrons induced in the secondary. And that I name coil number 1,
Ядерная обмотка.
the nuclear effect coil,
И вторичка.
and the secondary.
Вот это. Выходная.
And of course, as you see, he put a light bulb at the end of it, which will actually correspond to the previous video that he made, stating that the self-impedance of the light bulb is a part of the resonance circuit. So if you add more light bulbs, you would increase the resistive component of the impedance, and by that, if we're talking about changing resistance due to the temperature, we will detune the system. So the number of light bulbs and the wattage of the light bulbs is critical here.
Вот почему тесловская резонансная система нужна. Для того, чтобы минимальными токами получить большие токи.
And that's why we need a Tesla system or Tesla circuitry, because using a very, very small current, we are able to create a huge response.
ВВшка тоже резонансная, для того, чтобы прибавить еще напряжение и получить килоамперы в импульсе. А почему импульсная еще система Тесла? То есть импульсная. То есть когда вот эта вся система в резонансе, то есть любое в нее вмешательство нарушит вот эту резонанс.
So why do we need to have a very precise impulse in here? If we have any additional impurities or any additional disturbance, then we lose the resonance in resonance phenomena in this part of the device.
Поэтому все эти добавки мы не можем напрямую снять нагрузку. Мы можем только через промежуток искровой.
And now he implements the spark gap, where he says that we could only have a proper transformation due to the spark or due to the ionization. I'm not sure what he meant here.
То есть когда две системы абсолютно независимы.
But actually, we need to have a system at which we have two parts of the system completely independent, the one on the left hand side and the one on the right hand side.
Мало того, эти две системы могут находиться друг от друга на километр.
Huh. And that's interesting, because he says right now that those two systems could be apart 1 kilometers and more. So yes, we're dealing with the power transmission of Tesla in here. That reminds me Dinatron experiments as well.
Если задействовать систему передач импульсов, так сказать, через общую атмосферу, беспроводная система передач, она работает аналогично.
So if we build the system of transfer of the power over the air, we would achieve the goal.
Ну, будем работать со сплавиком, потому что нам сейчас нужны минимальные затраты, максимальный результат.
So we need to have a minimum of losses and maximum of the effect.
Ну, вот так вот. То есть, по сути, схема данная будет выглядеть так. Будет блок контроля. Вот он. Будет выходная обмотка и первичка.
So we're going to have the impulse block, or the impulse circuitry, which is the square below, and then we have a primary and the secondary.
Это передающий. Вот оно. Сюда будет входить в этот блок частота резонанса, выводки для контроля.
And the frequency of the resonance will go into that square below.
Управляемые сигналы на силовой каскад. Второе. Блок контроля.
Then the output circuitry of the block will go to the primary, and the control circuitry
И изменение индуктивности вот здесь, для того, чтобы резонанс
will be able to control the frequency of the primary.
То есть этот блок все будет контролировать эту работу.
So at that point we have a self-adjusting circuitry that would be able to control itself if there are any changes.
Нам нужна съемная катушка будет. У нее
So I think he was drawing the transmitter on left hand side. Now he's showing
будет
the receiving circuitry.
в первую очередь за резонансом в этой катушке, то есть в съемной.
So now we have a block that is responsible for controlling the resonance of the output coil on right.
Заряда нашей емкости этой катушки.
And the capacitive component of that coil
Подавать сигналы для управления вот этим блоком.
will be able to create a signal that will then give us ability to have another circuitry that would be synchronizing two blocks, one on the left hand side and one on the right hand side.
То есть те пачки импульсов, которые будут сюда выходить, они будут соответствовать нужному времени.
And those impulses that are the bottom will be exactly synchronized with the impulses from the output coil on the right.
К резонансу вот здесь и для заряда. А длительность их, то есть длина этих импульсов, то есть время разряда вот здесь, будет регулировать именно разность потенциалов, нужная для заряда. То есть
At the time of oh boy.
это вот это,
So this block
который будет смотреть в первую очередь за резонансом в этой катушке.
will control the resonance on the output coil.
Вот оно. Второе. Он будет смотреть за напряжением
will control
заряда
the current
нашей емкости, этой катушки.
of the capacitive
И
coil,
согласно этому подавать сигналы для управления вот этим
and
блоком.
give the signals controlling the primary block
Те
of the
пачки
transmitter.
импульсов, которые будут сюда выходить, они будут соответствовать нужному времени, резонансу.
And those impulses that I draw on the bottom will be synchronized with the impulses on the coil on the right hand side.
Вот здесь и для заряда. А длительность их, то есть длина этих импульсов, то есть время разряда вот здесь, будет регулировать именно разность потенциалов, нужную для заряда.
And the length of those impulses will control the timing needed for charging the capacitance of that capacitive coil. Actually, I recall the second part of Lithuania experiment, which we were dealing with Carousels coil and the coil capacitor. Let's go further.
То есть надо будет нам 220 вольт здесь на контроле сделать.
And we need to have a 220 volts here.
Реактивка будет, конечно, выше. Будет 300 вольт реактивки.
And the reactive voltage will be even 300 volts.
Вот этот насчет расстояния искровика, я, конечно, заострил внимание, но мог бы об этом говорить. Расстояние вот этого искровика будет влиять лишь только на ядерные процессы.
And the distance between the electrodes of the spark gap, I assume if we decide to go for the spark gap, will then be directly responsible for nuclear response of the lead coil, which would be then the, he called it nuclear coil, nuclear effect coil. Now at this point he says that the spark gap will create impulses that will exchange the electric field into the magnetic flux.
По сути дела. И заряда. То есть будет создавать разницу спинов за счет влияния на ядра.
It will create a differentiation of the spin of an atoms due to the interaction with the atom,
Вокруг которых двигаются электроны. То есть, влияя на ядерные процессы в металле, мы можем управлять электронами.
Well, he says that due to the controlling interaction in the nuclei, we are able to control the electrons. I take it the way that it is. I take it the way that he explains it.
То есть задача-то наша. Так вот.
Well, my understanding is that he is trying to explain nuclear magnetic resonance, but at the same time he states about the nuclei being under the control on the influence of the very strong current, and then the number of electrons or the electrons positioning being controlled. I could say in this point that well, yes, if we create the electron inhalation, then we would create a hole in the orbit K, L, M, N. Those are the orbits or the shells where the electrons are. On K we have 2 electrons, on L we have 8 electrons, L we have 18, and M we have a 36. Oh, yeah, 32. Okay, and if we then are able to create electron inhalation, which I don't see the basis right now for it yet, then by creating a hole in K we creating an attraction for the electron from LMN to jump into K, and then by that the electron has to lose its own energy, and when it's losing that energy, is manifesting that energy in the X-ray. So that will be the photon of X-ray in the X-ray region. But sometime in that hole, not the electron from the directly shell above could jump, but one from the far away N shell. So then we're talking about the high potential in it, and we're talking about the higher level of the energy. We should remember that in that region the energy stays about the frequency. So the higher the energy of the photon, the higher the frequency of the photon, and so on. But let's go further.
Этот блок. Да, ну и он еще же будет, конечно, управлять силовым каскадом, то есть включаемым, который будет управлять стоковой обмоткой.
And then you will need to have another block, which he explained before, and that block would be the primary, and that is a tacting or the keying circuitry for the primary. That the reason for that coil is to control the interaction of the nuclear effect coil and the output coil on the right, where the light bulb is connected.
Вот этот блок. То есть этот блок готов. Вот он.
And that's this block.
Я очень долго мучился. То отставание сигналов обработки, то отставание от этих сигналов. То есть очень 3 дня я просидел с этим блоком, прежде чем его нормально сделать.
So I spent about 3 days before I was able to somehow be able to adjust that block.
И управляемые импульсы, которые идут тоже низкочастотные, не так важно. Вот это важная система. Ее реакции, то есть надо же еще учитывать будет тянучесть резины, растянутость всех процессов, которые будут происходить в силовом блоке и в самих катушках. То есть, ну, удалось сделать. Сейчас у меня здесь стоит, так сказать, модератор, который вот этот сигнал пропускает через себя.
I have a modulating circuitry in here, right exactly where the arrow at the bottom is, that is capable of using the signal that's coming from the right hand side block and modulate the block on the left hand side. So he's talking about the synchronization.
Для чего нужен еще здесь модератор? Для того, чтобы контролировать ток в резонансной обмотке и вольты.
The modulating circuitry is needed to control the current of the primary coil and the voltage. So actually current times voltage is power.
Если мы жестко можем контролировать здесь вольты в резонансе, мы можем жестко контролировать вольты здесь.
If we are able very strongly and precisely to regulate or control the voltage on left hand side coil, we are able to do the same on the right hand side.
Если мы можем жестко контролировать амперы здесь, мы можем жестко контролировать амперы.
And also the current as well.
Да, еще забыл. Вот этот еще один управляемый сигнал будет для создания тока в импульсе.
So we need additional circuitry also to make the current in impulse.
Ядра именно вот этого проводника. Так, ну еще раз. Блок готов. Ключи только надо нормально. К этому все блоку пришло.
So you see the block?
Вот у нас здесь силовой модуль, я его до этого показывал. Вот он, я к нему собрал блок управления.
And that's the generating circuitry
Резонанс.
of resonance.
и держит резонанс, регулирует резонанс первичной обмотки. Вот он этот кон.
And this one is controlling the resonance of the primary coil, this coil.
Управляемый через нагрузку перитовую, изменяя индуктивность вот этого контура, мы изменяем.
And it is winded on the ferrite. I understood it this way. Now look at that. You have a horizontal and vertical structure of the coil, and it's a typical structure for the nuclear magnetic resonance.
Меняем индуктивность нашей первички для того, чтобы она совпадала, резонанс здесь совпадал четко с вышкой.
So we need then the primer of the Tesla coil to be exactly in resonance with the secondary of the Tesla coil.
То есть вот он будет, этот звук, это как на него будут приходить сигналы, регулировать длительность импульса, вольты контролировать.
And this block is responsible for timing of an impulse and the voltage
И амперы в разрезе.
and a current in the spark gap. Well, we don't have a spark gap in here, but we could say that he is talking about a equivalent of the spark gap, which would be a timing generator for the discharging the impulses.
Часть тьмы стоят блок управления второй катушкой. Дома больше включать, наверное, не буду. Сейчас пойду на улицу, только проверю. То есть
I'm not gonna switch it on right now. I'm gonna go outside the house and
наверное,
take a break.
забыл выключить. Все это из-за глубинного торопливания. Так что Артур на твой счет. А сила в импульсе здесь очень большая. В принципе, второму видео будет слышно и видно.
Sorry for the quality of the sound that I had during my translation of Akula device. Not gonna redo it, it's just too much time. For me, understanding of the process is kind of much easier than he explained that. So we take from the left hand side, draw the schematic that would be inverter 12 to 220 volts. Then at the end of it we have 12 volts and 220 volts. Right, so then from the 12 volts we putting a diode, still dealing with the AC current, and diode will actually limit the presence of the lower part of an impulse, so the frequency will drop twice. And then from the output of the diode we're going to the high frequency circuitry, which would be a generating board, and that board is synchronized due to the upper part of the impulse that is received from 12 volts AC from the inverter. Then we have a 2 legs output of it, and we put in parallel one diode, strong diode, and a coil, and that would be our primary coil. There will be the resonance in resonance. We don't have to add additional capacitor into it, but we could if we want to, just to tune it. And then the next coil to it is our Tesla coil, which is he called that the nuclear effect coil, and that coil one end will be in the air and the other end will be connected to the choke, the choke winded on the ferrite. We could also regulate or adjust that choke. So what we're trying to do is the impulses that we got from the primary coil will never go to ground, will be stopped by that choke. So the choke is connected with one side with the lower part of the Tesla coil, and from the other side is connected to the ground. And of course to one side of the 220 volts transformer. Now the other side of the 220 volt transformer is something that is being quite unique. We have two coils connected in series, one at the lower part and one at the upper part of that coil. And then we're gonna have another capacitor, which would likely be 1 microfarad of 1 kilovolts. And that capacitor will be connected from the very top of two series coils, which is next to the wire of the nuclear effect coil hanging in the air. And due to the through the capacitor we have a sort of insulation, because the other side of the capacitor is connected to the other side of the transformer and then to the ground. And then we have a light bulb, and the light bulb is connected to one side of the transformer and the capacitor and the choke in series with the Tesla coil. And from the other side it's connected to another choke on the ferrite, and that choke is connected directly to the second coil of the two coil structure. So imagine that you have a long, big, huge one coil. That's our Tesla coil. You have two coils, one at the bottom, one at the top. So few wires on the bottom and few wires on the top of the same Tesla coil. And could be wound under the same structure, let's say inside the Tesla coil. That's how I see it. Now, the impulses that will be given from the high frequency block, due to the presence of the diode at two legs of the high frequency block, and then of course we have a coil connected to parallel that would be our primary coil. When you have a diode, you actually have a right upper part of an impulse, and we try to synchronize those impulses so they are present only at the discharge part of it. So the amplitude of the typical impulse goes up and then goes down, and when it goes down, then we are giving a peak. There is of course a different way of understanding. Arunas states that we should give those peaks right before the maximum of the amplitude of the impulses, which I sort of agree with that, but I understand how it works. Now the explanation is that when we are able to create in those two coils in series a strong impulse, then from the other side of the capacitor 1 microfarad and 1 kilovolts will have a sucking of the electrons, sucking of the voltage from the ground. And the bigger the current that is going from the ground, the more energy comes to the light bulb. I know that I'm explaining that without any schematic in here, but it's gonna be a time. I would like to give a special thank you to Tiger. Tiger is amazing brain. Tiger is somebody absolutely talented. I would say, despite the presence of Tariel Capenaze, Tiger is like me. I mean, Capenaze is for money. Akula doesn't want to give up all of the secrets he's explaining. He's educating, well, the same as Romanov and a few other guys. It's greed. It's a typical human nature. Well, he's trying to be truthful. That's why Akua is giving us all of the explanation. He wants us to understand that this is not a hoax and not a joke, and not just a cheap popularity. So he has to give up something, but he doesn't want really to give up enough for us to do it. And should I blame him for it? No, I don't. I mean, why should I? Why should I? I mean, talking about Tiger and me, we don't give a damn. What do you have? We want to give out. There is adaptation also to, let's say I have it in my hand to create a patent or application, which patent never gonna be given unless people try to repeat it, and to patent it just to restrict big guys, the huge corporation, from making big money on it, but let them for the first time pay to the public. So I see that this way, that yeah, the application is made, and the licensing fee for those big LGs, GMs, and all other big companies would be then, you want to make a production, go ahead. You're gonna be paying savvy. And from that money, you still would be able to sell it to wealthy, but it would be enough money to fund the parts for free to millions of us. Sort of tax, legal one. Good one, because I don't have to pay the taxes from it. The corporation paid me royalties, and royalties then was given to the non-profit organization. Non-profit organization is buying the parts for the millions of the people, and don't pay taxes of it. And there would be automatic stimulation for those people who wants to build it. I've got a part for free. All I need is just to make it happen. So I gotta learn something. It's a stimulation for education. Yeah. The big guys want us to be stupid. The big guys want us to be idiots. The big guys want us to listen to cheap music, and interest in sport is highlighted. So you have to spend the money going to all of these events whatsoever. But then, did you ask yourself what is left over? What is afterwards left in your hand and in your head? Did you become smarter? Can you make more money? I mean, you were watching TV 12 hours out of 200 channels that you have in your TV, or 800 channels, and you got nothing. There is nothing usable. They call it science. It's a science for idiots. So, that's my comment at the end of it. I believe that in year 2013 we are going to have a change, and that change is gonna happen. I'm dedicated to humanity, and I'll be this way. I'm not for sale to anyone. Wesley, STIVEP, number 1. It's my channel. STIVEP, Sierra Tango India, Victor Echo, Papa 1. So long for now. Have a good time.